What's up, pre-calculus homies? I hope you've not reached your limit with limits, because we're not finished with limits just yet. Pretty soon though, we'll be finished with limits. And today will be a pretty easy one. We're going to talk about like two main things. So learning target on the board, students will. One-sided limits analytically or algebraically, and then also finding limits at a vertical asymptote, which also involves using one-sided limits. So without further ado, I'm going to get rid of me and we can see the notes. And we'll try to go through this as fast as I can. I'm going to keep this video under 15 minutes. Okay, that's a goal. How do you find limits as you approach 2 from the left? That's what question 1, I guess part A is asking us, the first part of question 1. 2 with a little minus sign means as I approach 2 from the left side. So think of a number that's on the left side of 2, left of 2. And you look over here at the graph, left of 2 would be like 1, and then 1.5, and 1.9, and 1.999. As you get closer and closer to the left side, what is the limit? What is the y value? The y value here is this number, -3. Okay, so algebraically, how do you do that? You literally plug 2 in to the equation. 2 minus 5 is -3. Cool. So then how would you answer the second part here of question 1, where you're going 2 from the right? You would do the exact same thing. You don't have anything else to do differently. You only have the function x minus 5, right? And so you got to plug 2 into it. Even though it's from the right side, it's still 2 minus 5, which is -3. Pick a number on the right side of 2, like 3. Greater than 2 is 3, to the right of 2. Or 2.5, or 2.1, or 2.01, or 2.000001. As I get closer and closer to 2, from the right side, I'm still approaching this y value of -3. So remember the limit, from going back to that very, very first worksheet that we ever had on limits 2 weeks ago, the limit is the y value at this place. The third part of question 1 is asking what's happening as you approach 2 from both sides. So when you do not see a little minus sign after your number or a little plus sign after your number, when it's just a number and no plus or minus direction behind it, it means both sides, which means that the left side and the right side have to agree with each other. The left side and the right side have to be the same answer. So in order to answer this third part of question 1, you would have to do the first 2 parts, even if they weren't there, okay? So look, what's question 1 now? Question 1 is, what's the limit as I approach 2 from both sides? Oh, how do I do that? Well, first I have to check the limit on the left. Then I check the limit on the right. And since they are the same, I know the limit from both sides is 2 minus 5, which is -3. Okay, graphically, you would look at the graph and make sure it's the same on both sides. If you just have a function like x minus 5, you plug 2 into it and you're finished. Okay, there is no algebra to really have to show here. Do you have to write 2 minus 5? You don't have to. -3 is the answer. Like it's pretty simple. Now, when you get to example 2, problem 2 is maybe a little more fun, a little more challenging. And notice on problem 2, there's no graph. So I'm going to try to like get away from the graph a little bit. With each one of these examples, I might bring a graph up and talk about a graph. But as I approach 2 from the left, the first thing you're going to do is plug in 2. You hope that when you plug in 2, it's just 2 minus 5, and the answer is -3. Now, in this problem, what is 2 squared? 2 squared, that is 4. And what's 7 times 2? 7 times 2 is 14. So what is 4 minus 14? That would be -10. And what's -10 plus 10? -10 plus 10, 0. Over, what's 2 minus 2? 0. So when you plug in 2 to this function, even though it says 2 from the left, you don't really worry about the left. You only have one thing to plug it into. What is going to happen, you'll see very, very soon. Example 3. Now you can see all of it. With one-sided limits, you do get piecewise functions very often. So that's a lot of what we got to talk about today. Review piecewise functions and how that it pertains to limits. With example 2, it's not a piecewise function. There's only one function. It's a fraction. Now, what does 0 over 0 mean? 0 over 0 means do more math, right? Do more math. This means I'm not finished yet. This means that I can somehow take, and how about we take a new color while we're at it? I can take this function and I can somehow rewrite it as like, maybe x minus 2 times x minus 5 on top divided by x minus 2, because what is negative 2 times negative 5? That's positive 10. What is negative 2x minus 5x? That's negative 7x. So the top part factors. When it factors, notice the x minus 2 factors, common factors, are removed. So I have a removable discontinuity. Whenever you see 0 over 0, you know right away there's a removable discontinuity at that number, in this case 2, because 2 is the number that gave me 0 over 0. Removable discontinuity means there's a hole in the graph at 2. Dear Eliza, there's a hole in the graph. And so what am I going to do now? Now I'm going to use this function that I have left over, the factor x minus 5. Well, this kind of looks like the very, very first problem that we did at the top of the page. Look back at the top. Look back up there. See? Plug in 2 now. 2 minus 5 is negative 3. So what in the world just happened? What in the world just happened was this particular graph on problem 2 would look exactly like the blue curve that you see up there, okay? Except, boom, there's a hole there. Dear Eliza. So we've changed the graph from problem 1. Now it's the graph that belongs to problem 2. Okay, in problem 2, we didn't have a line, we had a fraction, we had a rational function, is what that's called. Not a linear function, it's a rational function. But it simplifies to being almost a linear function, except at one point, right? This fraction differs from the line x minus 5 at one point. So that's kind of kooky and crazy and weird. Okay, the answer to 2 is negative 3. So when in doubt, if you're doing limits, maybe just guess negative 3. Maybe that could be the answer. So how do one-sided limits, left and right limits, change from the both sides? The big difference is you don't do anything different unless you have a piecewise function. Because what will happen very often with one-sided limits is piecewise functions. I was just going to go to here. Piecewise functions take over. Piecewise functions, one, look very kind of confusing, and two, they can make the questions more exciting. Just this week, I gave some practice FRQs for my AP Calculus class, and like one of the first questions on there was a piecewise function. F of x is equal to, and it was like 2 parts, different than this one, but still. So piecewise functions, not something we've like spent a lot of time with, but it's been there before, and hopefully you're not too freaked out. First step is, what's the limit as I approach 4 from the left? Well, see, this time, as I approach 4 from the left, again, the left side of 4 would be numbers like 3, or 3.5, or 3.9, or 3.9999999. And where does 3.99999 fit? 3.9 is less than 4. Left of 4 means less than 4. And so when I ask you, what's the limit as I approach 4 from the left? You're only using the top piece. The top piece is x minus 5. Oh, that looks familiar. We had that earlier. And so what is 4 minus 5? That's negative 1. Cool. Part B, what's the limit as I approach 4 from the right? See, now the little plus sign means the right of 4. Right side of 4 would mean like 4.1, right? Or 4.01, or 4.001. Those are all numbers greater than 4. So piecewise functions and one-sided limits kind of go together like a matched, set. Because the one-sided limits means to make sure you pick the right side, left or right, and piecewise functions usually pivot around that number that we're looking left and right of. So what's the right side of 4? I still just plug 4 in, but notice which piece I'm going to plug it into now. I'm finally using something different than x minus 5, right? I'm going to plug 4 into the other function, which says 4 minus 4 squared minus 1. And what is 4 minus 4? Well, that's 0 minus 1. Well, 0 squared is 0, minus 1 is negative 1. So part A and B have the same answer. Now when I go to part C says, what's the limit as I approach which side of 4? That means both sides of 4. There's no plus, there's no minus, it means both. which means you must now do parts A and B first. So if A and B were not there, see how they're not there anymore? If those questions were never there, and question C was the only question, okay, then what you would do is parts A and B. Boop, boop. See, there's a graph down there, hiding down there. So since A and B have the same answer, then answer for part C is -1. This is kind of different than the first example at the top of the page. For the first example at the top of the page, I just plugged 2 into x minus 5, and 2 minus 5 is -3. I kind of didn't really need the first two parts. But here, when I try to do part C, I have to plug 4 into part A and into part B. There's two different pieces of a function. Okay, so I did make a graph for this function, and I went ahead and made the graph before you guys showed up to speed up time. I'm hoping this video, will go quick. Notice what is happening with this piecewise function is it's a line, right? It's the line x minus 5. The top part is a line, but then the second part at x equals 4 is a parabola, because it's x minus 4 quantity squared. And it just so happens that that parabola right there and that line happen to intersect at the same xy coordinates, right? It's a system of equations that intersect at that point. So this happens to be a piecewise function. That's pretty nice because it's a continuous piecewise function. Even though I have two different functions, they come together right now at 4, right? The two pieces come together at 4. So what if I had other parts, like question D here is like, what's the limit as x approaches 6? Well, I would hope that 6 is really easy because 6 is greater than 4, right? So you would use the bottom piece. You could even look at the graph now. Oh, it looks like if I go over to 6, my answer is up at 3. And that's because 6 minus 4 is 2. What's 2 squared? 2 squared is 4. What's 4 minus 1? 3. Okay, so the answer for D is 3. I just plugged 6 into the bottom piece. Question E, what's the limit as I approach -10 from the left? I always think that the negative numbers with the left direction are kind of fun because there's like minus signs on both sides of the numbers. It just kind of looks funky. So again, which piece contains the number -10? -10 fits into which part of the domain? And that's by going back up to the top of this function here, you see that the two rectangles there, those are what are called the domain restrictions on the piecewise function. Domain restriction. So the domain has to be less than or equal to 4 to use the first part, right? You're restricted to that first piece when x is less than or equal to 4. And -10 is less than 4. Okay, if you're not sure, it is. -10 is less than 4. It's to the left of 4. So I would do -10 minus 5. And -10 minus 5 is -15. The fact that it's from the left side really doesn't even matter here. Because if I went, and I didn't make my graph go back this far, but -10 is way back here, right? And I go down to my graph, it's in the middle of a line. So -10 from the left, -10 from the right, -10 from both sides is -15. That's the y value, okay? So I made up a whole new problem. Whole new problem. Oh no, it's the next one. Never mind. That's example 5. Sweet. Well, sorry, I didn't do the graph here. Shoot, I was getting ahead of myself. Hopefully it's not 15 minutes yet. This one looks very similar to example 3. I tweaked it a tiny little bit. So let's see what's up. Find the limit as you approach 4 from the left. Which piece of the domain contains 4 from the left? Like, 3, 3.9, 3.99. Those are all less than 4 or left of 4. And so you use the top piece, x minus 5. So 4 minus 5 is -1. So the limit from the left is -1. What's the limit as I approach 4 from the right? Notice this time, the right side of 4 would mean greater than 4. To the right of 4 is a number like 4.1, right? So if I plug in 4 there, what's 4 minus 4, quantity squared? That's 0. So what has happened was, and I thought I had drawn the graph, but I didn't. I can do this pretty quickly. 1, 2, 3, 4. Red. There's a line right here at 4, -1. And the line, it's got a y-intercept of -5, so it's down there, right? And then there's a piece of a parabola, because x minus 4 quantity squared is a parabola that would sit on the x-axis at the point 40, that's its vertex, and it would go up, happy face parabola, but it's only half of the parabola because it's greater than 4. Notice this is a function. If you draw a vertical line, it passes the vertical line test. Even at 4, I did pretty good there. It goes through the dot and it goes through the hole. So it only touches the graph in one point when you draw a vertical line. So this is a piecewise function. It is a function. It is not a continuous function, okay? This function is broken. Unlike the blue curve you see up there, it connected. It was very nice, you know? It's like, you know, when people are nice. What's happening here is you got a couple different people and they're like disjoint, right? They're broken. In order to answer question C on part 4, you have to look at the limit from both sides, which would mean answer A and answer B have to be the same answer. In this case, they are not. So when they're not, what's the answer? The limit does not exist, right? And if you go back to Mean Girls, there was an asymptote. But what she says, while she's answering the quick recall question at the end of the game, she says, if the limit does not approach anything, then the limit does not exist. Lindsay Lohan. Heck on it, Marty. And so if you think about it here, as I get closer to 4, the limit does not approach anything. Technically, it approaches 2 different things, right? From the left, I'm going to -1. From the right, I'm going to 0. So you can't have 2 different limits. That's the complete opposite of what a limit is, right? Like, I've reached my limit. I can't take anymore. And then, look, you took more. So apparently, it wasn't your limit yet, you know? Sometimes I think the human person, human beings, the human soul, the human body, the human, you know, drive, spirit, dedication can take more than maybe you think. You know, you're like, I can't do this anymore, and you just got to keep fighting the good fight. You know, run one more block. You know, go one more mailbox. You can do it. Okay, push yourself further. You can do it. But if you get 2 different limits, the limit does not exist. Okay, this is not a removable discontinuity. What's happening here is called a non-removable discontinuity, and specifically, it's called a jump discontinuity because you jump from one piece to another. I'll draw a picture of all the different kinds of vocabulary. I'm not too concerned about that right now, but if I use the words, that'll help, right? This is called a jump discontinuity. Cool. So example 5. I'm practicing. This was a different kind of piecewise function that I thought of. Notice here, it doesn't say less than and greater than. This is x not equal to 3 and x equal to 3. So as I approach 3, question A, what's the limit as you approach 3 from the left? As you approach 3, that means closer and closer to 3. That does not mean at 3. That means closer and closer to 3, like 2.999999, right? And so where does 2.9 fit? 2.9 is not equal to 3. 2.9 is here, right? 2.9 is not equal to 3. So what is 3 times 7 plus 13? 21 plus 13 is what, 34? Okay, cool. What's the limit as you approach 3 from the right? The right side of 3 would mean like 3.1, 3.01. And 3.01 is not equal to 3. If you have $3 and a penny and I only have $3, then you got me beat, right? 3.01 is not equal to 3. So I'm still using the top piece, right? 7 times 3 plus 13. Turns out that's 34 again, right? 21 plus 13. And then part C is what's the limit from the left and the limit from the right, right? Part C is both sides of 3. Again, both sides of 3 are still at 34. If I could do a quick graph of this, just a sketch, not really a graph, but a sketch. What's happening here is I have a line. I have a line whose y-intercept is 13, the slope is 7, so it's a pretty steep line, right? And if I go over to 3 on this line, right around here is 3. What's actually happening is there's a hole. There's a hole at 3, and that hole fell out, right? It's like it pooped out a dot, and it landed at 9. So if I ask you to make a new question, question D, what is f of 3? F of 3, or it's not f though, it's q. I used q because, you know, q, 713. This would be the point 39. 39's cool. Q of 3 is is 9. That is the y value at x equals 3. But the limit as I approach 3 from either side and both sides is at the whole, right? Because as you get closer and closer to 3, the limit is the y value at this discontinuity. Okay, cool. I'm trying to rush. If you need to go back and watch the video and pause it and write the notes down, I should have said that in the beginning. Might be times where you have to pause something and then write the notes, and then you can like watch me go through it. Oh well, oops. So here's a problem that I have the answers already written down below, and you see there's a little bit of a graph there. I'm going to cover it up. This is a piecewise function. How many pieces does this one have? At the count of 3, let's all say it out loud together. 1, 2, 3. 3! Very good. See, there's 3 pieces this time. And I asked a whole bunch of questions. Do you need to draw a graph? No. I kind of rather you not draw a graph because we've done limits from a graph before. I think having a graph is helpful, but you're not really supposed to draw a graph. It takes up a lot of time. So at this point, I'm about ready to show you the answers. So I'd like for you to pause this. You're going to have to write down these questions, write down the function. Maybe go get a drink of water, maybe get a snack, then come back and work out the answers. Okay, and then unpause it, the video. And what I'm going to now do is scroll down to the answer key. Okay, so if you haven't paused it yet, pause now. Okay, so now it's a time where you're unpausing and I'm scrolling down to the answer key. Okay, answer key. And I try to color coordinate this for fun. There's 3 pieces. I labeled them blue, red, and green. Okay, part A. And how about we pick yellow? What's the limit as I approach 7? Okay, ignore the graph for a moment. You first figure out where 7 fits into the domain. 7 is greater than 2. So, oh, Martin Joseph, that's so funny. And I got the first one wrong. How cool is that? So what is 7 minus 7? 0. I had 7 on the brain, I guess, when I did that one. So 7 is greater than 2. 7 minus 7 is 0. Okay, part B. What's the limit as x approaches 1? Notice 1 fits into the middle piece. 1 is between -1 and 2. Okay, so I plug in 1, and 1 times 2 is 2 plus 1 is 3. Part C. What's the limit as x approaches -3? -3 is less than -1. So it's the top piece, and -3 squared is 9. Okay, so parts A, B, and C had nothing to do with -1 and +2. -1 and +2 are the parts where this graph is kind of like balanced around. Right? It's the parts where the graph changes. It's the values where the graph changes. And so to do part D, what's the limit as approaches -1 from the left? So -1 from the left is which piece? It's the blue one, the top one. Because the left side of -1, okay, left of -1 would mean like -2. -2 is left of -1. Negative, and I'm kind of showing it on the graph now, -1.5, -1.1, -1.01. As I come down the graph, the left side of -1, you're coming down the parabola, down, 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 right? And you're approaching what number? Well, you're approaching -1 squared, which is 1. Notice the graph does not equal, there's no solid blue dot, right? Because I'm on the blue piece, I'm coming down to -1. Like I'm at -1.00000001. As I approach -1 from the left, I use the top function. And I just plug -1 in and get -1, okay? Question E, what's the limit as I approach -1 from the right? See, on the right side of -1, I'm at like 0. And even still, 0 is really, really far away from -1. So you want to get closer. Like go to -0.9, -0.99, -0.99999999999 is on the right side of -1. It's just greater than -1. -0.9999999. Negative numbers are tricky because they work backwards. This will be a little bit better maybe when we get to 2. Negative numbers are definitely trickier. So as I approach -1 from the right, I'm on the second piece, the middle piece, the red piece. And 2 times -1 is -2, plus 1 is -1. And so the limit from the right side of -1 is -1. The limit from the left side of -1 is +1. So question F, what in the world are you doing, Marty? I I messed the question up. Whoops. So, I don't know my own strength. Presto. Nothing on my sleeve. What's the limit as I approach -1 from both sides? I meant for question F to be -1 in my brain. I was like, oh, +1. So the answer to question F is correct. It's 3. You are on the red piece. Man, this has been too long. I had to make this whole worksheet up and then kind of like work it out, and now I'm making the video, and so sorry. You are on the red piece for question F. I meant to ask, so I'm gonna ask it up here. Here's question E.5. Right before we get to F, what's the limit as x approaches -1 of m of x? What's the limit as I approach -1? Which side of -1? The left side or the right side? That means both. Both the left side and the right side. They have to be the same answer. And are they the same answer? So in order to answer question E.5, you have to do D and E first. And so E.5 is D and E. D and E. Yeah, D and E. It's I didn't make this up. It just happened. Damn. Question F. It was supposed to be -1. It's +1. Again, at +1, you're fine. I already asked this question earlier. Man, I am mixing up like X's and Y's in my brain today. Question F is 3, because 2 times 1. It's already part B. Part B is the same as part F. I totally messed that up. Oh well, I'm not going back to redo this video now. Question G, what is m of -1? What's the function's value at -1? What does y equal when x is -1? And that's where the red dot is. Okay, the red dot is -1, -1. And so the bottom red dot, the lowest red dot. H is what's the value of m at 2? What's m of 2, or the y value when x is 2? Again, I could technically use either function, the red one or the green one, but technically I'm supposed to use the green one because that's where the equals is. Okay, it just so happens that the green curve and the red curve intersect. So I tried to draw that over here in the graph. I made a red circle and then I colored in the red circle with a green dot. So remember the red curve, it doesn't say equals 2, only the green one does. But since they happen to come together right now over 2, they intersect at 2, you could get away with picking either function, plugging in 2, and you would get 5, right? So m of 2 is 5 on H. I is what's the limit as I approach 2? Again, which side of 2? That means both sides of 2. Both sides of 2 take me to 5, the left side and the right side. I would have to do 2 questions to answer part H, or part I. I have to look at the red part and the green part, and as I get closer and closer and closer to 2, the y value is 5. Ta-da! Cool. So that was somewhat of a train wreck, but oh well. What's next? Okay, this part's going to go fast. Again, if you need to, go back and rewind. Watch different parts again if you need help. I made a worksheet that has both of these kind of questions on it. At this point, you could stop and maybe do half the worksheet. The part that has the part that doesn't have vertical asymptotes. It might be hard to tell. It's easy to tell because on the worksheet, a lot of the piecewise functions are the ones that don't have vertical asymptotes. How do you find the limit of a vertical asymptote? Well, the left and the right still matter. The left side and the right side are still a big deal here. Okay, so that's sort of implied, and sometimes it's written explicitly, but here you notice on question 7 is not. And I went ahead and drew a graph on problem 7. I didn't do a graph, I don't think, for the rest of them at all. I can do it as we go along. First of all, vertical asymptotes, in case you forgot, they show up when you have a fraction, and that fraction has already been simplified. And when any number in that simplified fraction's denominator equals 0, you have a vertical asymptote. Okay, so vertical asymptotes occur when the denominator of a simplified fraction equals 0. The fraction has to be simplified. Okay, like the example that we just saw up there earlier. Remember, x squared minus 7x plus 10 over x minus, it was 2. Okay, what's happening here is x cannot equal 2. If you let x equal 2, you get 0 in the denominator. But it's not a vertical asymptote, right? This was problem number 2, way at the top. This problem would have a hole at 2. It's a removable discontinuity. It's indeterminate form because it's 0 over 0, okay? I have to simplify the fraction first and then look at the denominator. When you simplify this fraction here, okay, what happens is the denominator becomes a 1, right? Because the factor of x minus 2 cancels out. Well, in problem 7, the fraction is 1 over x. 1 over x is already simplified. You can't reduce it, you can't factor it, you can't cancel anything out. It's 1 over x. So what happens if I plug x in, 0 in for x, right? That, again, for every limit, you always try to first plug the number in and hope that when you plug in 0, you get like 7. So in this case, I got 1 over 0, and 1 over 0 is undefined. Undefined means vertical asymptote. Undefined will always mean vertical asymptote. I already wrote undefined, you moron. Vertical asymptote. So when you have a vertical asymptote, there's kind of 3 answers that can happen, okay? This means you could get infinity. It means you could maybe get negative infinity, or it means you could possibly get D and E. As I approach 0, I could get one of those 3 answers, okay? And this is 0 from which side? This is 0 from both sides. So the left side of 0, right? The first question you have to ask yourself is, what's the limit as x approaches 0 from the left of 1 over x? And do you need to write this down? No, you don't really have to if you can do it, in your head. I drew a graph, so the graph is very helpful. I love doing limits from a graph, especially when the graph's already given to you, right? So imagine if this graph wasn't there. You'd be like, I don't have a graph, so you have to draw the graph. So boom, I drew the graph. Wait, undo. There we go. So what's the limit as I approach 0 from the left? The left side, I'm coming this way, right? Like the left side of 0 is negative 1, negative 0.5, negative 0.1. And notice the graph's going down, 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 forever and ever and ever. As you approach 0 from the left, the answer is negative infinity. What's the limit as you approach 0 from the right? Well, the right side, you're at like positive 1. Positive 1 right here. And I'm approaching 0 from the right, like positive 1, positive 0.5, positive 0.1, positive 0.01. And as I get closer and closer and closer to 0 from the right, notice the blue curve, it goes up to infinity and beyond. And is negative infinity and positive infinity the same answer? No, that it is not, right? Those are different answers. So if you have different answers, the limit does not exist. So 1 over 0, it's not an answer. You don't give 1 over 0 as an answer. Undefined is not the answer. You don't give that as the answer. You don't say undefined. Now, when you get undefined, that pretty much means D and E, okay? D and E, undefined is D and E. The issue is sometimes we can answer with infinity and negative infinity, and that's better, okay? So I'm totally cool with you always knowing that it's D and E. Whenever you have a vertical asymptote, technically the answer is always D and E. However, if you can ever state infinity or negative infinity, you should. On this problem, you can't, okay? Because it's 0 from both sides, it must be D and E. The answer must be D and E, okay? Multiple choice questions on the AP exam. What did you do here, Marty? I guess this is where I'm at. Multiple choice questions, they would usually have infinity or negative infinity, okay? So that's why I can't just let you put D and E every time. I need you to be able to understand when it's infinity and when it's not. So like example 8, I think I have 3 more examples, okay? 8, 9, 10, and we're done. This video has not been 10 minutes or 15 minutes. So oh well, I owe you guys a donuts. Sometime, somewhere, someday. Okay, how do I do the limit as x approaches 2 of 1 over x minus 2? Notice there's no graph here. I didn't draw a graph. What you're going to do first is plug in 2 and hope you get an answer. What is 2 minus 2? That's 0. 1 over 0 is undefined. Undefined means there's a vertical asymptote, okay? This means vertical asymptote. If it was 0 over 0, that would mean what? Everybody say it together. 1, 2, 3. A hole in the graph, right? 0 over 0, a hole in the graph. That would mean you're going to get an answer. You have to do more math. 1 over 0 is basically going to mean D and E. It's possible that it could mean infinity. It's possible that it could mean negative infinity. So how do I know? What do? I have to check the limit from the left and limit from the right. So I wrote these two parts down here, okay, just to get ahead of the game. I wrote them down there. How do I check the limit from the left? From the left side of 2, you want to check numbers like 1, 1.5, 1.9, 1.999. Okay, and notice I don't have a graph. If I could just pull out a calculator, and type it in, 1 over x minus 2 into y1, it's really nice to just be able to use a calculator. A lot of the AP exam, you don't get to use a calculator. So what do you do when you don't have a calculator and you're not sure, does this graph go up to infinity or does it go down to negative infinity? Because that's what's happening here. You know there's a vertical asymptote. Okay, so I know my vertical asymptote is at 2. 2, dot, 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 dot. Right, what I'm trying to figure out is what's happening at 2. Does the graph go up to infinity or does it go down to negative infinity? Okay, so how do I know is I need to check a couple of numbers. Basically, it's like plotting the graph in your head or just sketching it real quick. So for example, pick 2 numbers to the left of 2. Basically, I'm just going to make a graph. Let x be 0. Instead of picking like 1 and 1.5, I would pick 2 numbers that like are better numbers to work with, like plug in 0. And what is 0 minus 2? That's negative 2. What's 1 over negative 2? Negative 0.5. This is negative 1. Here's negative 2. Now I'm going to plug in 1, right? Let x be 1. What's 1 minus 2? 1 minus 2 is negative 1, right? Maybe we should write this down. Let x be 0. Y is negative 1/2. Let x be 1. Y is negative 1. So when I plot that, notice that dot's down there. When x is 1, y is negative 1, which tells me the graph is being drawn towards the asymptote and it's going to go down forever. The limit from the left side is negative infinity. Negative infinity. So at this point, maybe you're thinking, oh, the answer is negative infinity. Well, remember the question was actually both sides of 2. So I need to check the right side. And maybe you're thinking, well, on the right side, it has to go to positive infinity, doesn't it? It doesn't necessarily have to. No, it doesn't. So we have to check. I need to check 2 numbers on the right side of 2. And I would check 3 and 4. 3 and 4. 3, 4. Let x be 4. If x is 4, what is 4 minus 2? 4 minus 2 is 2. Y is 1/2. It's up 1/2. Let x be 3. See, I'm getting closer to 2 from the right. 3 is closer to 2 than 4 is, and it's on the right of it. And 3 minus 2 is 1, and 1 over 1 is 1. So at 3, the graph goes up to 1. So look at what's happening. It's going up. Oh, which means the limit from the right side is positive infinity. So the limit from the left is negative infinity. The limit from the right is positive infinity. Those two things do not agree with each other, right? So what is the answer supposed to be to this question? The limit as I approach 2 from both sides has to be, everybody say it together, 1, 2, 3, D in E. Because the limit from the left and the limit from the right do not agree. If we had the graph to begin with, you could look at it and go, oh, D and E. Now, I made up example 9 on purpose because I don't want you to think that whenever you have a vertical asymptote, it's always D and E. Notice what's happening on 9. It's almost the exact same question, except it's squared. The fraction is squared. So very quickly, I could actually make this graph very easily because I go over to 2 and there's a vertical asymptote. Because when I plug in 2, again, the first step is plug in 2. I got 1 over, what is 2 minus 2? 0. 0 squared is 0. 1 squared is 1. It's still 1 over 0, which means vertical asymptote. But what happens to the rest of the graph when you square it? Well, this half of the graph over here, when you square it, just becomes more positive. It actually gets steeper faster. What it does. What's going to happen to all the negative numbers when you square them? All the y values, when they're negative, would get positive. So what's happening in example 9 is that the limit from the left side, as I approach 2 from the left side, the limit as x approaches 2 from the left is infinity. What's the limit as x approaches 2 from the right? My stylus, the little nubby that I write with on the stylus is actually worn down to nothing. So it's actually not, and I'm writing too fast. I'm trying to get this video over with. What's the limit as I approach 2 from the right side? It also goes up to infinity. So you see how example 9, the answer would not be DNE. That's a pretty good infinity symbol. I like that one. The answer on 9 would be infinity. Now, technically, infinity is not a limit, right? So the limit doesn't exist here, but infinity is a more descriptive answer as to why it doesn't exist. When you say the limit is infinity, it's better than just saying no, right? It's like the reason why it's no. The limit does not exist because the graph goes up forever, and it goes up forever on both sides, so I can say infinity instead of DNE. Okay, so subtle difference between 8 and 9. 8 must be DNE, 9 must be infinity. Okay, but if you wrote DNE, it's not wrong. I'm just saying you need to write infinity. If this were a multiple choice question on the AP exam, the answer would be infinity. Okay, now they would not have infinity and DNE. They wouldn't put both answers on the multiple choice because that'd be terrible. Which one do you pick? Okay, so if it's multiple choice, well then cool. You know it's infinity because it's only thing there. They would also probably put negative infinity, so you have to make sure you pick the right one. So cool. Notice in order to answer question 9, I still had to do the limit from the left and the limit from the right. So this whole one-sided limit business is a big deal. Okay, so what the heck? Example 10 has 2 parts. I don't remember anymore why I made this one up. So what's happening here in example 10? Notice I'm going to plug in part A, plug in 3. What is 3 minus 3? 3 minus 3 is 0. What is 3 squared? 9 minus 9 is 0. What's 0 over 0 mean? Do more math. That's 0 over 0. So what am I going to do here is I'm going to factor this. X minus 3, x minus 3, x plus 3. Those are the factors. What's the limit as x approaches 3 from the left? Notice the x minus 3's cancel out. And I'm left with a 1 on top. And now I can plug in positive 3. And what's 1 divided by 3 plus 3? The very last step of every limit problem is actually applying the limit. See, we're not in class for you all to like not really pay attention. But people would ask me in class, like, I don't get in the end, how did you get the 1/6? What did you do? Notice I wrote limit and then I wrote limit. But right here, I don't have to write limit anymore because I'm plugging in 3. Like once you actually plug in the number, you're applying the limit. You're taking the limit one more time. Okay, let's pick up purple. I haven't used purple yet. Question B on 10 almost looks like the exact same problem. Minor differences. What's the negative in front of the 3 mean? It means negative 3. So plug in negative 3. What is negative 3 minus 3? That's negative 6. Over what's 9 minus 9? 0. And negative 6 over 0 is undefined. Undefined means a vertical asymptote. So I have a vertical asymptote at negative 3. I have a hole in the graph at positive 3. This graph is all kinds of beat up. It has 2 different types of breaks. It has 2 different types of discontinuities. One break would be a hole, which we call removable discontinuity. The other break is a vertical asymptote, which is a non-removable discontinuity. This non-removable discontinuity is not called a jump discontinuity, but it's called an infinite discontinuity. So at a vertical asymptote, it's called an infinite discontinuity. And I go back to this graphs up here, right? So remember the jump discontinuity is I had one piece here and then another piece. It's almost like for a jump discontinuity, there's a graph with with 2 parts to it. So it's almost like I could jump from one piece down to the other piece. I could jump from one to the other. Okay, they're split vertically from each other, so you can jump. It's just you jump across the thing. But what's happening with an asymptote is if I were to jump here, I wouldn't have any other piece to land on, right? The other graph on example 8, if I were to jump off of this piece, I would go down that. If I jumped off this piece, I would go down that way, right? So infinite discontinuities are what they call vertical asymptotes. Again, I'm gonna draw another picture of this another time. I have notes on this already. We might have taken in class by now, or maybe we wouldn't have. I don't even know. But infinite discontinuity versus a hole in the graph versus a jump discontinuity. Those are like the 3 types of breaks. 2 are non-removable, 1 is a removable discontinuity. So what's happening at negative 3 is from the left side, I need to figure out, okay, here's negative 1, negative 2, negative 3. I know there's a vertical asymptote. right? At -3, there's a vertical asymptote because I got 6 over 0. 6 over 0 means vertical asymptote. Okay, notice I have to simplify the fraction, right? See, when I plug in +3, I still get 0 in the denominator, but getting 0 on top means that it's not a vertical asymptote. Notice when I simplify the fraction, the part that's down here, I'm going to circle this red thing with purple. See the purple box that's forming? Okay, there it is. See, there's the simplified fraction. The simplified fraction is 1 over x plus 3. And what number for x makes this denominator equal 0? The number that makes the denominator 0 of a simplified fraction is the vertical asymptote. So the vertical asymptote shows up at -3, -3. It's the number that makes the denominator of a simplified fraction equal 0. Okay, so +3 makes the fraction's denominator equal 0, but that's not when it's simplified. +3, when you simplify it, does not make the denominator 0, right? It makes the denominator 6. 3 plus 3 is 6. Anyway, I just need to figure out what's happening at -3. Is the graph going to go up to infinity, or is it going to go down to -infinity? We're almost done. This is the last one. Okay, how do you know? Well, one way to know is you have an inherent sense of graphs, and you know what the asymptote does, and you know that like when it's a positive number on top versus a negative number on top, the graph might go up or down, things like that. You could also know what the graph is doing because you looked at the graphing calculator. And maybe the graphing calculator is allowable on this question. I'm not sure. So what am I going to do? I'm going to let x equal -5, and then I'm going to let x equal -4. Oh, dang, this kind of sucks. And I got to figure out what y equals. When I plug in -5, what's -5 minus 3? That's -8. What's -5 squared? 25 minus 9. What's 25 minus 9? 25 minus 9 is 16. Right? That's nice. And notice -8 over 16 is -1/2. So it's at -5, which is back here, I'm down -1/2. Then let's plug in -4. What's -4 minus 3? -4 minus 3, y is -7 over, what's 16 minus 9? 16 minus 9, because -4 times -4, 16 minus 9 is 7. And -7 over 7 is -1. Same situation as the last problem that we did, example 8 or whatever that was. So notice what's happening is my graph gets closer to the asymptote. It's going to go down. Because from -5 to -4, it went down. So it's going to go down. If you want, you could even plug in -3.1. Now the issue is plugging in -3.1 is a really hard thing to do, right? So it'd be nice to use a calculator. Well, if you get to use a calculator, don't type in any of this stuff. Just go to the graph and graph it, you know? So the answer here is -infinity. The limit as I approach -3 from the left. -3 from the left is -infinity. Okay, so piecewise functions and vertical asymptotes. That's like the new flavor of the day. I got a worksheet that you can work out now, and I'll post the answers tomorrow. Good talking to you guys. I hope you've had fun. I love you. Bye.